Every train you see weighs thousands of tons, and all of that weight is held up by rocks. No concrete, no steel foundation, just crushed stone. But here's the crazy part. If you removed these rocks, the tracks would start failing in just days. So why do railways depend on something this simple? And how do these small stones hold up entire trains? Those rocks are called ballast, and they're one of the most important and most overlooked parts of any railway. Most people think the rails or wooden sleepers carry the load, but that's only part of the story. The real work happens underneath. A single freight train can weigh over 10,000 tons. Without ballast, all that pressure would be focused on a few narrow points. The ground would compress, the rails would shift, and the track would lose alignment. Ballast solves this by spreading the load. Each stone transfers force to the stones around it, creating a wide, stable platform beneath the track. Instead of crushing the soil, the weight is distributed, but weight isn't the biggest problem. Water is. If rain collects under the tracks, the soil becomes soft and unstable. Over time, this causes sinking and dangerous shifts. Ballast works like natural drainage. Water flows through the gaps between stones and away from the track. Without ballast, railways would slowly collapse from below. In the early days of railroads, engineers didn't fully understand this. Some tracks were built without proper ballast, and the result was constant derailments, uneven rails, and endless repairs. It took years of trial and error before they realized that simple crushed stone was the missing piece. Here's something most people don't realize. These rocks aren't round. They're sharp on purpose. Round stones would roll under pressure, but angular rocks lock together. They grip each other and resist movement. That's what keeps tracks stable during braking and turning. It's why railways never use smooth gravel. High-speed railways in Japan and Europe still use ballast for most tracks. Even with modern technology, sensors, and automation, the foundation remains the same: sharp stones and gravity. Sometimes the best solution doesn't need an upgrade. So why not just pour concrete? Because concrete cracks. It traps water, and it transfers vibration directly into the rails. Ballast absorbs shock. It's flexible, cheap to replace. When sections wear out, workers simply remove old stones and add new ones. There's one more job. Ballast does that almost no one talks about. It makes maintenance possible. Over time, tracks slowly move out of alignment. Temperature changes, vibration, and heavy loads push everything around. With ballast, engineers can lift sections of rail, adjust the position, and pack new stones underneath. Without it, every small correction would require rebuilding the entire track. Beneath every railway is a quiet engineering miracle. Millions of small stones working together to support enormous machines moving at high speed. No computers, no electronics, just physics and smart design. What's fascinating is that almost every country uses the same idea. Different trains, different climates, same solution. Because physics works the same everywhere. Next time you see train tracks, look down. Those rocks aren't decoration. They're the foundation of the entire system. If you like discovering the hidden side of everyday things, you'll love this channel. We turn simple questions into fascinating stories about science, engineering, and history. Subscribe if you want to keep learning something new. There's a lot more coming.